Welcome back, ladies and gentlemen, and we are in the middle of naming organic compounds. So let us jump right in, and we've got to draw this molecule. Consider 3-methylpentane. Well, I have an idea about pentane. Remember, last time we said there are 3 types of hydrocarbons that we had: alkanes and alkenes and alkynes, right? And we said that alkanes have all single bonds, alkenes have a double bond in there between the carbons, and alkynes have a triple bond in there. And we learned that when we name these that we have a suffix and a prefix. And the prefix tells me about the number of carbons, right? That 1 is meth, 2 is eth, 3 is prop, 4 is bute, 5 is pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. So if this is pent, that means I have 5 carbons. If it's ane, that means I have 5 carbons, all of them single bonded. 1, 2, 3, 4, 5. That's perfect. But what's this stuff going on here? Well, that indicates something new. Okay. And we're talking here about naming hydrocarbons. And last time we really talked about naming simple hydrocarbons. What I just told you about, the prefix plus the suffix, that is for simple hydrocarbons, meaning unbranched. Okay, unbranched. Good. Well, there's another type that we're going to call branched. And what is a branched hydrocarbon? That means there is a group, or when I say group, something other than hydrogen, something other than hydrogen bonded to a carbon. And so this could be something like, if I have this picture, okay, let's take methane, and then I put an OH here. Well, then that would be a group. Or I could put propane, and then I could put another group down here. And you'll find out that that's really not propane. Here's my propane, and then here is my branch or group. Good. So that's what we're talking about. It's just it's not a straight chain of carbons. Now, what are typical branches or groups? What are my typical branches? I can have a methyl group. And what is a methyl group? Well, it's a CH3. Or I could have an ethyl group, and that would be C2H5. And what does that really mean? I guess I don't like C2H5. It's really more of a C2H3. That is an ethyl group. And oops, let's draw that better. So really, when you see this coming off of the side of something, that might be a methyl group, ethyl group. We could have a propyl group. We might have a fluoro or a chloral. A chloral means that I have a carbon, not a carbon, a chlorine popped onto it. Something like that. These are typical branches. All right. Now, how do we recognize what's the form of, kind of all over the place here, zoink, oops, yoink, yoink, yoink. Na. What's kind of the form of my name for a branched hydrocarbon? Well, we have something like a number, and then we have the branch, and then we have the, I guess I'll call it the main chain. Okay, so something like 3-methylpentane. The pentane, that represents the main chain. The methyl represents the branch. And the 3 tells me the location of the branch. And what do I mean location? That means the carbon on which branch exists. And so how do we go about doing this? First thing we do is we write our pentane. 1, 2, 3, 4, 5. On the third carbon, so now I have to number my carbons, either left to right or right to left, it doesn't matter. So I'd go 1, 2, 3, 4, 5. On the third carbon right here, I put a methyl. What is a methyl? A methyl is a CH3. So on my third carbon, I'm going to put a CH3. And then I'll fill in the rest with, we can get rid of our numbers now. We'll fill in the rest with my hydrogens. Remember, each carbon needs to have 4 bonds, so wherever I don't have 4, I have to put in hydrogens, right? And this would be 3-methyl pentane. Here is my pentane. On my third carbon, I have a methyl group. 3-methyl pentane. Now that's kind of the general form, and in a second we'll go through naming. Let's see if we have an answer here. Oops. 3-methyl pentane, yes, we've done 3-methyl pentane, just did it. So I guess just to complete things, we could put it on the bottom here. It doesn't matter where that methyl group goes, as long as it's on my third carbon. That's not pi, that's hydrogen. There you go. There is 3-methyl pentane. You guys give 2-methylhexane a try. Bring me back when you're ready. Well, where do we start? Hexane. Well, I'm going to put 6 carbons. 1, 2, 3, 4, 5, 6. I'm going to have to number these. I'm going to number them down low so it doesn't get in the way. Doesn't matter if you go right to left, left to right. I'm going to go from left to right. 1, 2, 3, 4, 5, 6. Whoa, what was that? Hey, that was strange. 6. On my second carbon, right here, I'm going to put a methyl group. Methyl group means I have a CH3. So I'm going to put an off my number 2. I'm going to put a methyl like that. And then I'm going to fill the rest of the carbons in with hydrogens so that each carbon has 4 bonds. And there you have it. That is 2-methylhexane. 1, 1, 1, 2. On my second carbon, I have a methyl group. Great. Let's do another one. 3,3-dimethylpentane. Okay, what's different here? I have my pentane, but now I have 2 numbers. And I also have something else here. Okay, when I have 2 numbers, that still tells me kind of my address. Where do the methyl groups go? Excuse me, where do the branches go? Since it says 3 twice, that means what? I'm going to have 2 branches. Now, what are those 2 branches? Well, di represents 2. So what this tells me that if I have more than one of the same branch, I'm going to use a prefix. So I have methyl. And how many methyls do I have? Dimethyl. That means I'm going to have 2 methyls. And we usually only see things like di or tri. You usually don't see tetra or anything else. So if you have 2 of the same group, it's di. If you have 3 of the same group, it is tri. So here we go. Let's draw our pentane. 1, 2, 3, 4, 5. I'm going to have to extend my page here. It is 3,3-dimethyl. Dimethyl means I have 2 methyls on the third pentane. Excuse me, third carbon. 1, 2, 3, 4, 5. A methyl group on the third. Another methyl group on the third. That means it's going to come to the bottom here. It's kind of ugly. Let's get rid of my number so I have more space. Good. And now we just complete my carbons with hydrogens. And this would be 3,3-dimethyl pentane. I have a pentane, 1, 2, 3, 4, 5. On my third carbon, I have one methyl group. On my third carbon, I have a second methyl group. That means that is dimethyl. And where are those methyls? 3, 3. Now, what if one of those was on the second carbon? Let's say this guy was not on that carbon, but was on this carbon. Then what would this be called? Well, I still have two methyl groups, so it's still a dimethyl, but it's no longer 3, 3. It would be what? 2, 3-dimethyl pentane. Hey, that's not so bad. Yeah, it kind of makes some sense. Good. You guys do 2,4,4 trimethyl octane and bring me back. Not a bad one, is it? We have octane. That means I have 8. 1, 2, 3, 4, 5, 6, 7, 8. I have 3 what? Methyl groups. So I have 3 methyl groups. Where are they going to go? One is on the 2. Let's just for the heck of it label from right to left this time. 1, 2, 3, 4, 5, 6, 7, 8. Of course, you could do it the other way. Both answers are correct. I have a methyl group on the 2, so 1, 2, so I'm going to put a methyl group here. And then I have what? 2 methyl groups on the 4. 1, 2, 3, 4, so I need a methyl group here and a methyl group here. And then I'll fill the rest of this in with hydrogens. I'm just going to leave these as lines, but all of these are essentially hydrogens. Okay, and so that would be 2,4,4 trimethyl octane, or of course you could switch your numbering and that would be completely correct. If you numbered the other way, zoink, let's change this. If you numbered the other way, it would be, where's my 2 if I number the other way? This would be 1, 2, 3, 4. I'm going to cheat, watch this. Let's take that. Oops. Good. So now this is 1, 2. What? Oh, there's 1. This is 1, 2, 3, 4. Have to put a methyl on my number 2. 1, 2, 3, 4, 5, 6, 7, 8. Hydrogens all around. Okay, so if you numbered from left to right, it would look something like this. 1, here's my 2 carbon. There's a methyl group on my 2 carbon. 3, here's my 4 carbon. 2 methyls on it. It would be what? 2,4,4 trimethyl octane. All right. Now, let's start naming some of these. It's easier to draw them than name them. So let's go back and let's take some notes on how do you go about naming. How do you name these branched hydrocarbons? Let's go with a different color. Blue. I'm going to come from this side. Naming branched hydrocarbons. Naming branched hydrocarbons. Naming branched hydrocarbons. Okay, it's not difficult, but I'll give you the process. Number 1, find the longest continuous chain of carbons. Okay, we're going to pop back and forth. Find the longest continuous chain of carbons. And what that means is I can't backtrack. So this could be a chain right here. This could be a chain. Now watch. Because it's all continuous. That could be a chain. And if we count these, this is 1, 2, 3, 4. For that chain, this one would be 1, 2, 3, 4, 5. Let's see if can I make a longer chain. I can't backtrack. What if I went oops, Eeks. Let's go this way. Do 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 do. I'm gonna come down here. Do 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 do. Gonna come down here. Do 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 do. That is 1, 2, 3, 4, 5, 6, 7. So I have 7 carbons. That would be my longest chain. Got it? Now you notice it doesn't have to just go straight. Doesn't have to go down. It can weave around as long as I don't backtrack. So that means I can't come over here and then come back down here. That's a backtracking when I come over to this one. So find your longest continuous chain of carbons, which we have done. Then what? We want to number them. Number these. Number carbons, starting with carbon closest to my branch. If more than one branch, then number so that your total number on the branches is minimized. Branches is minimized. So if I can number and I have 2, 3, or I can number and have, let's see, I can number and have 1, 3, or I can number and have 2, 4. I want to go with the 1, 3 because when I add them up, it's equal to 4. When I add 2, 4, it's up to 6. So I want a number so that my total number on my branches is minimized. You'll get a hang of this. So I could either number here 1, 2, 3, 4, and then I have a branch. 5, and I have a branch. 6, 7. So that means I have a branch on the, 4 and 5. Or I could number in the opposite direction. Let's go with red. I can number 1, 2, 3, and I have a branch on the 3. And then 4, 5, 6, 7, and I have a branch on the 4. So in this case, my numbering is better if I go from left to right, because then I have a branch on the 3 and on the 4. Got it? Aha. Now what do we do? I think you guys can guess what's going on next, right? Next, what do? We are going to name the longest chain, and then name the branches. Name the branch or branches. Use die try if more than one of same branch. Okay, this is not a very clean process. I understand that, but I hope you're gaining enough ideas to be able to do this. Good. So we've identified the longest continuous chain. We've numbered them. My chain was what? 1, 2, 3, 4, 5, 6, 7. I have 7. All my bonds are single bonds. That means I have an alkane. What do you call a 7-alkane? You call it a heptane. On this heptane, what do I have? I have this branch and this branch. Those are both what? CH3s are methyls. So it's a methyl heptane. How many methyls do I have? 2. That means di. Where are those methyls? Well, I have a methyl on the 3rd carbon and a methyl on the 4 carbon. So we'd call this 3,4 dimethyl heptane. All right, it's not so bad. You guys give this one a try. Bring me back. Well, first thing we want to do is find the longest continuous chain. That would be 3. Is that longest? No, I don't think so. What if we went this way? Is that a longest continuous chain? No, that's 3. That doesn't work. What else? How about if I go here, 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 here? Okay, that means I have 1, 2, 3, 4, 5. I think that would work. I think 5 is my longest continuous chain. Now we want to number this. I could start here, and that would be 1, 2, 3. This would be a 1, 2, 3, 4, 5. And then I'd have And if we go to the red, I'd have something on the 2, and I'd have something on the 4. If I go in reverse with black, this is 1, 2, 3, 4, 5. I'd have something on 2 and something on 4. It doesn't matter. They're both the same. Good. So I have 1, 2, 3, 4, 5. All those bonds are single. So that means it's what? It is a pentane. What kind of pentane? Well, I've got 2 groups. They are both methyls. That means this is a dimethylpentane. Where are those? On the 2 and on the 4. 2,4-dimethylpentane. Excellent. A couple more and then we'll call it a day. Aha. What do we have to do here? Well, we've got 2 things going on here. I've got a triple bond, and we know we have to number that, and I have a group. Okay, the rule here is if you have a multiple bond, you want to number so that the multiple bond, the double or triple, is on lowest carbon. That makes it easy in numbering, right? That means, first of all, I find my longest chain. Here's my longest chain. So 1, 2, 3, 4, 5. I want to number from left to right so that my triple bond is on 2. If I numbered from right to left, it would be on the 3, right? This would be 1, 2, 3, and then my triple bond would be on the 3. I don't want it to be on the 3. I want it to be lowest, so we're going to go from left to right. So how do I name this? It's 1, 2, 3, 4, 5. It's a 5er, so that means it's a pen. But I have a triple bond. That means it's not a pentane, it's a pentyne. I've got a group on it. What kind of group? A methyl. I have a methyl group, and on what carbon is that methyl? The methyl, excuse me, need to leave a little space here, don't I? I've got a methyl. And where is that methyl? The methyl is on the 1, 2, 3, 4. It's a 4-methyl. And where is my triple bond? It is on the 2 carbon. So this is 4-methyl 2-pentyne. This 2 tells me that the triple bond is on the 2nd carbon. This 4 tells me the methyl group is on the 4 carbon. Got it? Last one. Give this a try yourself and bring me back when you're ready. Easy, right? We find our longest continuous chain. I want a number so that my double bond is on the lowest carbon. So I'm not going to number from right to left. I'm going to number from left to right. 1, 2, 3, 4, 5. Those are my numbers on my main chain. I've got 5 carbons, so that means it's a pent. It has a double bond, meaning it's a pentene. Right, where is that double bond? It's on the 1 carbon, so we're going to call it a 1-pentene. I've got a branch. The branch is on the 1, 2, 3. So I'm going to have a 3 what? What kind of branch is that? Methyl. I have a 3-methyl 1-pentene. There you go. That's about as hard as I'm going to get. So let's call it quits for today. You are now experts at branched hydrocarbons. Bye-bye.